Hi guys. So what we're going to do today is review some things you learned about quadratics, both in Algebra 1 and in Algebra 2. So quadratics, the parent function is f of x equals x squared. It's the one that looks like a parabola, which is kind of like that U shape. So what we're going to do to start is just sketch a graph. All right, so these first two that you're going to look at are in what's called vertex form. Vertex form is easy to graph because it's easy to see your transformations as well as the vertex. So in that vertex form, h comma k is your vertex. So and notice it's x minus h in the parentheses there. So on this first one, in order to get to this graph, the first thing I'm going to plot is the vertex. So my vertex here is going to be 2, -9. And I'll go ahead and write that in here. Then we need to figure out if this graph opens up or down. So if it is positive out in front there, all right, it has not been reflected, it's going to open up. So if it opens up, that vertex is going to be the lowest point on the graph. Quadratics also have an axis of symmetry. That axis of symmetry is a vertical line that goes through the vertex. So your graph is going to be the same on both sides of that line. So that axis of symmetry is going to be x equals 2, which is the x coordinate of the vertex. All right, so now before we find the x and y intercept, let's go ahead and actually sketch the graph. So to figure out what this graph looks like, let's think about what the parent function does. So from the vertex, the way this graph moves, it's going to look like the parent function. The parent function goes right 1 and up 1, right 2 and up 4, right 3 and up 9. And that's how we move from the vertex. Now this graph has not been stretched, compressed, or reflected in any way, so it's going to move that same way from the vertex. So right 1 and up 1, right 2 and up 4 from the vertex, and right 3 and up 9 from the vertex. And then like we said, there's that axis of symmetry. So it's going to have the same thing on both sides there. And that is my parabola. All right, so x-intercepts, those are the points where it's crossing the x-axis. Now, we'll work on solving for those algebraically here in a little bit, but if you have the graph and you can see those points, we can just write those coordinates, -1, 0, and 5, 0. Then you've got the y-intercept where it's crossing the y-axis, which is 0, -5. If you want to find that point algebraically, to get the y-intercept, you could plug in 0 for x, and then you could solve algebraically and you'll get the same point. All right, let's try the second one. So the vertex is going to be -3, -1. Because there's a negative out in front, it's going to open down. Since it opens down, that vertex is a maximum. The vertex is -3, -1. So the axis of symmetry is x equals -3. And then let's sketch our graph. So from the vertex, we would go right 1, up 1, right 2, up 4, right 3, up 9. But we're not going to move that exact same way from the vertex because of that negative out in front. So instead, I'm going to go right 1 and down 1, right 2 and down 4, and right 3 and down 9. And that's my graph. Now you'll notice on this one, because the vertex is below the x-axis, and because it opens down, there are no x-intercepts. The y-intercept here would be 0, -10. All right, so now we're going to do the opposite. We're going to take some information and we're going to write the equation. So on this one, we're going to start by writing this in standard form. So standard form is the ax squared plus bx plus c. So what I'm going to do is I'm going to multiply this out. So remember, that means x plus 5 times x plus 5. So I'll go ahead and actually multiply those together. So x plus 5, well, let me go ahead and show you this in between step. Okay. Then I can combine those together. And then I can distribute that negative. And I end up with -x squared minus 10x minus 31. And that's standard form. All right, if you feel comfortable, pause the video, try this next one on your own. All right, so x minus 3 times x minus 3. Now, if you want to distribute that 2 first, you can. Just don't distribute it to both of them. It's only multiplied by one of them. Okay, you could have done the same thing with the negative again, as long as you only divided or multiplied it into one of them. So I'll go ahead and do that first this time. Again, it would be fine if you multiply those two together. So I end up with 2x squared minus 12x plus 19. And that's standard form. All right, let's try another one again. We're going to get some information and write the equation. So on this one, because it gives us the vertex, okay, it's going to be really hard to write this in standard form from the beginning. So we're going to start by using vertex form, which is ax minus h squared plus k. So when we fill in these values, the vertex is 3, 4. So 3 is h and 4 is k. So I'll go ahead and fill those in. Now the problem is we don't know what a is. So in order to figure out what a is, we're going to have to solve for it. And here's what we do know. We do know an x and a y. So this is an x and this is a y. So I'm going to replace that x with that x, and I'm going to replace y with 6. So now I can solve to figure out what a is. So 1 minus 3 squared would be negative 2 squared. I'll subtract that 4. Negative 2 squared is 4. Divide by 4, and then I get my value of a. So once I know what a is, I can rewrite this in vertex form. So now to write it in standard form, we're doing the same thing that we did on the previous question. So again, I will go ahead and multiply this out. X minus 3 squared is x minus 3 times x minus 3. And I'm going to skip ahead a little bit. Whoops, that should be minus. I can distribute that 1/2. I'll write 4 with a common denominator. And I get my answer in standard form. All right, if you feel comfortable, pause the video and try this next one on your own. All right, so again, we don't know a, so I'll fill in x, or h, and k. So my h is going to be 1, and my k is negative 6. Then I'll fill in the x and the y. So negative 2 is going to be a, negative 3 is going to be x. So I'll add 6 to both sides. Negative 3 plus 1 is negative 2. Negative 2 squared is 4. So a is 1. So this one is actually going to look just like vertex form. So now if I want to write this in standard form, okay, we'll FOIL that out. So x plus 1 times x plus 1. So x squared plus 2x plus 1. And we're done. All right, so what we're going to focus on for the rest of this is solving quadratics. So there are 4 different methods you saw for solving quadratics, besides graphing, which is actually a 5th method. The ones we're going to use the most often are going to be factoring and the quadratic formula. So the other methods that you saw last year, you saw completing the square, which is a great option if you remember how to use it. If you were interested in using it, we will spend some time talking about it, but it's not required for today. We can use quadratic formula and factoring. I will tell you factoring is going to be probably the most important one because we'll need factoring for other purposes besides solving. All right, so when it comes to factoring, there's a couple different types that we'll look at. The first step whenever you factor is always going to be to take out your GCF, your greatest common factor. Sometimes that's all you can do in order to be able to factor. So looking at this first one, I'm going to see what my common factor is. Both of those terms have an x. So I'm going to take that x and I'm going to factor it out. Now, the other thing whenever we solve by factoring, we need to make sure that it's equal to 0. Because if we do that, once it's factored, all we have to do to solve is take each factor and set each factor equal to 0 in order to get our answers. All right, let's try the next one. Take out our GCF. So both of those have a 2x. If I divide out 2x, I'm left with x plus 4. If I set each factor equal to 0, 2x equals 0, and x plus 4 equals 0. So I get that x equals 0, and I get that x equals -4. All right, let's look at some that are not just GCF. All right, now again, that first step has to be to set it equal to 0. Okay, we can't just factor on our own by solving. Okay, in order to solve, it has to equal 0 first. So the first thing I'm going to do is I'm going to subtract 3. Now, when we have 3 terms, we look at the first, what that coefficient is. If that coefficient is 1, these are our easy factoring questions. All we need is something that multiplies to the last number and adds up to the middle number. So the two numbers that multiply to -12 and add to -1 are -4 and 3. So because a is 1, because there's no number in front of the x squared, our factors are just going to be x minus 4 and x plus 3. Now, if a is not 1, we'll do some of those in a minute. It's going to take a little bit. So if the a value was something other than 1, this would take a little bit longer, and we're going to do a few of those here in a minute. So then at this point, it's the same thing as the other ones. We take each factor and set each factor equal to 0. So if x minus 4 equals 0, then x equals 4. If x plus 3 equals 0, then x equals -3. All right, if you feel comfortable, pause the video, try the next one on your own. All right, so we're going to set this equal to 0 first. Then I'm going to look for what multiplies to 8 and adds to -6. So we want it to multiply to a positive 8, so I can do 4 and 2, and if I make both those negative, those would add to -6 and multiply to positive 8. Set each factor equal to 0, and I get x equals 4 and x equals 2. All right, so now let's try one of those longer ones I was talking about when the a value is bigger than 1. Now, there's more than one way to do these. I'm going to use the method that most of your Algebra 2 teachers used last year. Now, whatever method you use, you're probably going to start with the same process. I'm going to take the a and the c, and I'm going to multiply them together. So I'm going to look for what multiplies to 2 times 12. So just like we did in the last one, except we're going to actually consider that first value as well. So I'm looking for something that multiplies to 24, and then I'm looking for something that adds to 11. Well, those two numbers are 8 and 3. Now, because this is not 1, I have extra work to do. I can't just write that as my answer. So what I'm going to do is I'm going to rewrite this middle using the two numbers I just came up with. So I'm going to keep the first term the same. I'm going to rewrite the middle. And I'm going to keep the last term the same. By doing this, I have the exact same equation because 8x plus 3x, that is 11x. I'm just rewriting it using those two numbers. Now we're going to use grouping. So I'm going to take these first two terms on the left, and I'm going to take out the GCF. So the GCF there is 2x. That leaves me with x plus 4. Then I'll go to the next two, and I'm going to take out 3x, and that leaves me with x plus 4. If those parentheses match, that means we did this right. So the parentheses are your first factor. Everything that's not in the parentheses, so that 2x plus 3, is your second factor. And I don't know why I wrote an x there. Sorry, guys. Extra x. Then same steps, set each factor equal to 0. So I get x equals -4. And x equals -3/2. All right, if you feel comfortable, pause the video, try the next one in your room. All right, so we're looking for numbers that multiply to 3 times -6. So they multiply to -18, and they add to the middle. They add to 7. So those two numbers would be positive 9 and -2. So I'm going to rewrite this and rewrite the middle. Now that I have this, I'm going to do grouping. So take out what's common from those two terms. Then I'm going to go to the next two. And when it comes to the sign, whatever sign's in front of that term, we're just going to keep that. So I'm going to keep that minus, take that 2, my parentheses match, set each factor equal to 0. So one answer is 2/3, and one answer is -3. So now we're going to go ahead and look at the quadratic formula. So the quadratic formula is another way to be able to solve quadratics. So the quadratic formula is listed over here. So you may see this, and you may recognize it from Algebra 1 and Algebra 2. Also, I apologize, guys. I'm starting to lose my voice, and I've started and stopped this video a few times, so if my voice sounds different, that's why. But what we're going to do is we're going to plug in those values to that formula. So whenever you have a quadratic, A is the coefficient of the squared term, so whatever comes in front of x squared. B is the coefficient of the x term, so whatever comes in front of the x. And C is the number that doesn't have any x's at all with it. So then we're going to fill in those numbers to that formula. So x equals -b plus or minus the square root of b squared minus 4ac. And it's all divided by 2a. So then from there to simplify, we're going to simplify what's in the square root. So -4 squared is 16 minus 8. So then I get 4 plus or minus the square root of 8 divided by 2. And then I need to simplify the square root of 8. So there's a couple different methods for this, but what most of you probably learned is to take 8 and break it down into a factor tree with its prime factors. Out of those prime factors that are in the bottom, you're looking for any pairs that you can find. So I have a pair of 2's. Any pair becomes a number on the outside of the square root. Anything that's left over goes inside the square root. So that is how I break down the square root of 8. Now, I want to point out a couple really common mistakes when it comes to using the quadratic formula. So the first mistake that most people make is at this step right here, dividing that 4 and 2 and saying that this is 2 plus or minus the square root of 8. Okay, we cannot do that. We can't just divide that one number by 2. Anything that's being added or subtracted here has to get divided. Now, the other mistake people make then is they say, okay, well, let me go ahead and divide this and divide the square root of 8. We can't do that either because a square root can only be divided by another square root. We can't divide it by a number. Okay, so what we do instead is we simplify it and we get to this step. Once we're at that step, the 4 and the 2 that are on the outside can both be divided by 2. So I divide both of those by 2, and I end up with my final answer. All right, so with quadratic formula, just like we did with factoring, we have to set these equal to 0 first. So I'm going to subtract the 2, and then I'll do -b plus or minus the square root of b squared minus 4ac all over 2a. And then we'll simplify what's in the square root. So that's going to be 16 minus 4 times 13, which is 52. 16 minus 52 is a -36. And then again, we're not going to divide by 2 yet. We have to have a number in front of the square root in order to be able to divide. So let's simplify that radical. The square root of -36. A negative inside a square root becomes an I outside the square root. So if you have the square root of -7, that's I, square root of 7. If you have the square root of -12, okay, well 12 we could break down. The pair would come out, the 3 would be left over. The negative on the inside becomes an I on the outside. And then with 36, we do the same thing, but we actually know the square root of 36. The square root of 36 is just 6. So this becomes 6i. Once you have that, divide both of those numbers by 2, so that becomes 2 plus or minus 3i. All right, let's look at one more. All right, so I'm going to go ahead again. My A is 2, my B is -11, and my C is 12. It's already equal to 0. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So 11 squared is 121. Minus 8 times 6 is 96. So I get 11 plus or minus the square root of 121 minus 96, which is going to be 25. The square root of 25 is 5. Now in this case, we're actually going to get a nice pretty number. We're not going to get something that still has a square root in it or anything that has an I. These are going to be referred to as rational numbers. And you'll hear that come up again later. So if you get a nice fraction or a nice whole number, those are rational numbers. So let's go ahead and actually find these. So we'll do 11 plus 5 divided by 4. So that's 16 divided by 4, which is 4. I'll do 11 minus 5 divided by 4. And I get my two answers. Now, like I said, since those numbers don't have any square roots, they don't have any i's, those are called rational numbers. What that means actually is that we could have factored this original equation. So not every equation can be factored. It'll only factor if you have those rational numbers for answers. But this one actually we could have factored and we would have gotten the same answers. If I factored it, I would have ended up with these factors, which would have given me those exact same solutions. All right, so if you feel comfortable, pause the video, try these last three on your own. These last three are actually the three that you guys did on your own at the end of class. But I'll go ahead and work them out so that you guys can see the answers. All right, so again, I need to start by setting this equal to 0. So minus x, and then negative b plus or minus the square root of b squared minus 4ac all over 2a. So then this is going to be 9 plus 56, which is going to be 65 over 4. And at this point, the square root of 65, that's not going to simplify any farther. The only factors I can come up with are 5 and 13. Those are both prime numbers. So there's no pairs, so square root of 65 doesn't simplify. This is as far as we go. All right, let's do 2 more. Again, if you haven't already, try these 2 on your own. All right, so negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is going to be 16 minus 4 over 2. So this is going to be 12 over 2. And then we're going to simplify the square root of 12. So I'll do the factor tree method. So that breaks down into 4 and 3 and 2 and 2. We got a pair of 2's. So 2 will go on the outside. A 3 is left over. It goes on the inside. If you ever have more than one pair or more than one number left over, those numbers will just get multiplied. Now both of those can be divided by 2. And you get your answer. All right, last one. Again, start by setting it equal to 0. So let's add 1. And then negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's 4 minus 20. It's going to be negative 16. So negative 16 would become an I on the outside, but the square root of 16 is just 4. So this is just 2 plus or minus 4i over 2. Both 2 and 4 can be divided by 2. And when you divide those 2's, they don't just disappear. 2 divided by 2 is 1. So there is a 1 out in front. All right, so that is a big quadratic review for you guys. We're going to be using these things in the next coming days whenever we do some polynomials.